Hello, in this video, we're going to talk about iterables in Python. So we're all very familiar with lists in Python and the fact that we can iterate over a list, right? So for example, we can print out each of the items in a list, just like this. So yeah, let me run that. And basically, yeah, it just prints out every single thing in the list. Now, so Python was something what it's something that can be looped over, as we just saw, or iterated over in a for loop. So it's actually an example of what's called an iterable. So the fact that you can do a for loop for every item in something that is an iterable is just what's called synthetic sugar. Synthetic sugar is kind of a syntax that is very simple, but it's hiding kind of behind the scene the complexity. So how it actually iterate over a list, what Python does behind the scene is really something like this. So first, and let me comment this out. So first, it gets an iterator from the list by doing L dot dunder iter. Now you can achieve the same effect by doing iter parentheses L. So it's the same thing. So this gives us an iterator over the list. And then we can do a loop. Okay, and every time around the loop, I'm going to get the next item from the iterator. So it.dunder_next. And this is just the same thing as next parentheses L, but I'm showing dunder_next because that's how it really works. So anyway, so this would do the same thing. Now let me run it, and yes, it prints out 1357, and we see something interesting at the end, that there is an exception that is called StopIteration that is raised, and the reason is that that's how the Python iterable signals to the caller that there's no more things, no more item in the iterator. So by raising this exception. So the right way to do this is to put this loop in a try except block, and we capture the exception StopIteration, so that when next raise StopIteration, it will come to this handling of StopIteration, and we don't need to do anything, we just stop. So that's how we can iterate something over an iterable very cleanly. Okay, so now obviously we don't really do this, because if you compare that one to that 6 lines of code compared to a for loop is far more simpler and more elegant, and very a lot more syntactically pleasing. Okay, but what this does mean is we can actually, for our user-defined class, that we can define our own iter, dunder iter, and dunder next, and have some a for loop iterate over a class that we define. Okay, so that's actually makes life very interesting. And as an example, as an illustration, let's write our own iterable that is called a sequential number iterable. All that it does is generate sequential numbers starting at 0, 1, 2, all the way up to some end, right? And so that would be, yeah, if you recognize it, it's just kind of a range a class or range function, but it's not yet full feature as range, but it's kind of like a range light. Okay, so let's start doing that, and I kind of already have the skeleton code here. So the first thing we want to do, obviously, we always want an initializer, and in the initializer, we want to know when to stop the sequential number iterable, right? So not much we need to do here, other than we just have to remember when to end. Okay, so that will be the initializer, very simple. the more interesting thing is the dunder iter. So remember what a dunder iter has to do. It has to return an iterator, and what defines an iterator is that that iterator must have a dunder next method defined on it. And iter is supposed to kind of initialize whatever's necessary for the iteration to start. So in our case, we want the first number, when we would generate sequence number from 0, we want to start at 0. So let's say, we start in the number that we want to start on is n, and we start at 0. And then we have to return an iterator. In this case, the object itself is an iterator because we're going to define the next. So it can just return self. You don't always do this, but for simplicity's sake, we don't want to define another iterator class. So we just keep it simple. Okay, so that's just that. That's all dunder iter does. Okay, so the next thing we'll do in the dunder next is we're supposed to return, the first time we're supposed to return n. So let's just remember what n is. Okay, and to prepare for the next time that we'll return, n plus 1, we'll increment the attribute n by 1. And then here we return n, which was, it starts at 0, and then the next one is 1, and so on and so forth. So that's really it. And I've defined an iterable here. And we can run it. Let me just make sure I've gone through everything. Okay, so let's run it. Let's do it the hard way first. So this is basically how iterating over an iterable works behind the scenes, right? With we first, in the instantiate iterable, we get an iterator from the iterable, which is just itself, and then we call the next in a while loop. So let's run this. And it keeps running. Yes, because as you look at this, there's the remember how an iterable ends. It raises a stop iteration. Now, inside dunder next, we did not raise a stop iteration exception. So we have to do that, and we do that when our n is bigger than the unfortunately named end. Okay, so if it's if it's bigger than or equal to, usually in computer science we don't include the end. The end is exclusive. So when that happens, then we raise stop iteration. Otherwise, we keep going. So now we want the end to be at 10. So let's hope that works. And there we go. So it goes from 0 through 9. And when n, which is 10 now, is bigger than the end 10, then we raise the stop iteration, and it's done. And that's all good. Obviously, this is, like I said, this is how it works behind the scene. There's a much easier way of writing this, and we can just say for I in this, we just print out I without all the ugliness. And there, it works exactly the same way. So look at what we just did. We actually define our own iterable that can be used in a for loop, just like the built-in list here. All right, pretty cool. Let's see. So I think, yes, now that I've demonstrated how to write an iterable, I would like you to give it a try yourself. So write an odd number iterable, and it does something very similar to the sequence number iterable, except that it generates positive and odd numbers. So odd number starts at 1. So, please pause the video and give that a try. And okay, so assuming that you have tried it, here is the answer that I wrote myself. It's very, very similar to the sequence number generator, except we start at 1, and then instead of incrementing by 1 every time, we increment by 2. And here's a demonstration that it works. All right, one more exercise for you. This one is slightly more involved. So write a Fibonacci number iterable that and get an n that returns the first n Fibonacci numbers. So, and if you don't remember what Fibonacci numbers are, they're these numbers 0, 1, 1, 2, and the way that is generated is each number is the sum of the two numbers before it. So 2 is 1 plus 1 equal to 2, 3 is 1 plus 2 equal to 3, and let's say, I don't know, 34 here is actually 13 plus 12. 21 here. All right, so give this a pause the video, give this a try. All right, assuming you've done that, hopefully you got it to work. Here is kind of my version of it. It more or less works very similarly to what we just said. A few more states variables that are involved. So first I want to keep an I, so that would be just the first 10, 20, whatever Fibonacci numbers, and then I have both an n and an n plus 1. So remember, we always keep track of two numbers, right? The 0 and 1, or 1 and 2, and 3 and 4, so on and so forth. So, and they start at 0 and 1, okay? And the next method is basically we stop when the I is getting bigger than the n that the user wants. And every time we increment I by 1, and obviously the way that the n and n plus 1 evolves is, n becomes n plus 1, and then n plus 1 is becomes n plus the O n plus 1. So assuming you've done it right, run through this, and that is the Fibonacci number of the first 20 Fibonacci numbers. Okay.